Good morning and welcome to our short session about how to decarbonize the industry. My name is Christoph Hiesgen. I am from E.ON Energy Infrastructure Solutions. I'm based in Essen and I'm here to explain a little bit the way forward, how to decarbonize food processing industry in the future, how E.ON can support and how we are partnering up also with suppliers and customers to develop the right solutions for the future. Afterwards, my colleague André Bechem will have the second part of the presentation. I will give a short introduction of the E.ON ICE business. Second topic is the need for decarbonization in the food segment. Third is key solutions for a seamless transition in the future, how to decarbonize, going away from fossil fuels to more electrical driven procedures. And then how to build the decarbonization roadmap for clients in the future. What are the difficulties? What are the hurdles? What are our expectations? How we can overcome the problems? And last point is really partnering is key for the decarbonization going forward with dedicated suppliers, with dedicated partners, because it's an overall problem for the society we have to solve. And therefore, we will want to give some small insights from our point of view. Next slide, please. First of all, a short introduction of the ICE business within the E.ON group. It's a small part of the whole business in E.ON, but we are in our business covering 15 countries across Europe. We have a revenue about 4 billion euros last year. I'm personally from the B2B business, so I'm serving industrial clients across Europe with solutions and developing projects together with my colleagues really to help and to support. And you see on the right-hand side a few of our clients we already have under contract with different kind of solutions and who are on a daily basis are talking to us how we can help them to decarbonize their future production and really get rid of fossil fuels and carbon emissions. What is our service offering? So we always describe a very clear roadmap when we are talking to clients. It's a 6-step. First, we describe the decarbonization roadmap by going really into the details, having site visits, analyzing what's going on site, do some measurements, and really then make a first proposal, first idea, how to come to a solution. Then the design is done by us. If the customer then agrees to our solution and is happy about it, about the savings, financially and also carbon driven, then we go to the delivery part. And what we also include is financing, as we are always very strong in financing our solutions to our clients, which are more interested in really funding their own solutions, their core businesses in production that we are also taking. We take care part for the whole O&M over a dedicated contract term. It can be 10 to 20 years. And we can add also another services, simply knowing the energy markets, how we can integrate such projects into the overall financial optimization of the future of our clients. You see some of our customers, I don't want to go to details, but all are very famous, either nationally well-known or internationally well-known brands. So they trust us and we have done some really great projects in decarbonization with them, coming also from the past, of course, from cogen solutions, but energy efficiency solutions as well. Really a bunch of projects we have done on that side and we can discuss. These are the 5 main developments we are going to promote. It's a strong push for decarbonization we see in the market. Everyone is asking us, how can we do this, especially under the ongoing threat we see in the current energy price development. We see very volatile energy markets, especially in power generation. Of course, if we are phasing out large-scale power plants in the near future in the most European countries and we have to renew the power, and how can we solve this? We see the high investment needs in that projects as well. And a very, very crucial topic is the shortage of skilled workers we have. We have to implement this project. And as you see, for instance, we are going to invest more than 43 billion euros in the next 4 years as E.ON Group in grids and projects across Europe. But we need really good and many skilled workers to realize all these projects, because here we really see a shortage in the markets. So the decarbonization done right will be, of course, for our clients as well as for us, a very big piece of the future business. And therefore, we really need to develop our solutions jointly with our customers. Next slide, please. We always build together dedicated projects. We do not take any project out of the shelf. Every project is unique in our development, and that's very core of our business we are doing. So what we are focusing here is heat pumps, and we will later talk about high temperature heat pump, because heat pumps as a mass product is not meant here. It's really the industrial design of heat pumps for high temperature processes. And this is, from our perspective, also the key driver in the future we need to tackle. So next slide, please. Here I've shown a typical solution of the future we see. So of course we need a large portion of renewable energies in the future. That means either on-site or mostly off-site, we need to generate green power. Green power can come from wind, solar fields, biogas, biomass solutions as well, and other sources in the future like hydrogen. But as long as we do not have really a mature market to replace natural gas by hydrogen, we really need to find other solutions, integrating PV, wind assets into the carbonization roadmap we see on our client's base. So if you deliver then the power on site, we want to install large-scale heat pumps using waste heat potentials from customer sources on site, from production processes, from cooling processes, for instance, or other environmental heat sources we see also like rivers, and then boost this up in a big heat pump to go to the future in the green heat. So we see here in a dairy process where we can do this. We can do it for cool storage. We can do preheating the cold milk, use pasteurization process and drying process in the future via heat pumps. These are the core elements we are going to identify. But what is key in all of these projects is really you have to look into the existing infrastructure on the premises of the client and what needs to be optimized there to run the heat pump in the most efficient way. Otherwise, the heat pump does not make sense if the system behind, the secondary system, is not really adapted to the heat pump. So this is a crucial part of the whole project, but there we run with our engineers into the field, look into the details at the client sites and go for that and make a proposal. And what are the key benefits? You can reduce your OPEX. If you are going to such a solution, you are pretty flexible and with regard to power and cooling generation, on the same page with heat pumps as well. You can reduce your carbon emissions by 100% with green electricity running a heat pump, and you have a fast installation without big disruptions of the processes your end. So this is something that is very high advantage for heat pump systems. Next slide, please. Yes, this is a typical process, how we are going into such projects. So first of all, we get in touch with you and make really the first presentation, what a solution could look like. If you're interested, we sign an NDA together to develop some and exchange some data information that is needed to run our simulations. What might be the best concept? Within 6 to 8 weeks, we make a first initial concept on such a project, and then we discuss it with our clients jointly if this is the right way forward, maybe where it needs to be fine-tuned, and how we can then come to the final project setup. And afterwards, when the decision is taken, then we really go on to the next steps and develop the project until the end, into the contract, into the realization phase, where we take responsibility for the execution and the transition planning, the testing, commissioning, and all stuff like that before we hand it over to our clients. And this is a typical way forward in our projects. And at the moment, we are running a lot of those projects across Europe. And you are sitting here in one of these buildings where we are also going to install a multi-megawatt heat pump to produce cooling and heating. So this is a very interesting project. So, and also being proud of it, being part of the project as well. So from our belief, heat pumps are really the core technology for the future to decarbonize the industry. And we are happy to support. And now I would like to hand over to André from Heaten.
Thank you, Christoph, for the nice introduction. My name is André Bechem. I'm the head of sales of Heaten. And now a few words about Heaten. So I think all of you are familiar with E.ON, but I think not everyone has heard about Heaten. Heaten has developed and produces and sells high-temperature heat pumps. It's a piston-based technology, with an industrial size of 1 to 8 megawatt per heat pump. We can reach up to 50 megawatt per system if we install it in parallel or in a cascade. And we can reach temperatures up to 200 degrees. And due to the piston-based technology, we have a very high efficiency over a broad operating range of between 20 and 100% load. And due to this, we are the most flexible solution on the market in this megawatt range. Currently, we have our head office in Kristiansand in the south of Norway, where we have our R&D and sales. In Remscheid, just 35 minutes from here, we have also our R&D department. We have the test bed and the testing, the manufacturing and the sales. We are supported in the development by a very strong partner, AVL. AVL is the largest independent powertrain developer worldwide, and they are the expert when it comes to piston-based engine and compressor development. And we are also backed by very strong investors. We have Azola Ventures, Shell Ventures, Nysnø, the Region State Climate Fund, and Valinor behind us. Next slide. Looking a little bit to the history, where we are coming from. So everything started in 2011 with an ORC-based system, so converting thermal power into electricity. The key know-how and knowledge about lubrication, the high temperature working fluids and all this stuff was already gained here. And then in 2017, the idea was born to make the process reverse. So in 2018, the first prototypes. In 2019, the first commercial available heat pumps were installed in the field. However, this machine worked great from the technology point of view, but they can only deliver 200 kilowatt each. And especially for the food industry, we get sometimes the feedback that this was a kitchen machine from the sizing. So now the logical next step was to make it much bigger. So we increased the displacement per cylinder with a factor of 8. And in 2023, we had the first HBL4, so heat booster large series 4-cylinder on the test bed in Remscheid. Next slide, please. What can one 4-cylinder heat booster do for you? It saves a lot of energy, so up to 1 million euros per year, depending on the case. A lot of CO2 emissions, so up to 2,800 tons per year. We have typical payback time between 2 or 4 years. Of course, case depending on the country, and you get independent from fossil fuel. And in addition, depending on the case, you can also save a lot of water because you can get rid of the cooling towers. Here you can see a bigger picture of our installation, as I said, in Remscheid. And the COP range is typically in the range of 50 to 55% of Carnot. We can reach high output temperatures. We also can use very high heat source temperatures, so up to 150 degrees. And we can directly supply steam. And due to the variable compression ratio, we can use all types of HFOs and hydrocarbons in the same machine. And the variable compression ratio also allows us to vary the temperature even with the same working fluid in the same application, with the same high efficiency. And as mentioned in the beginning, we have a variable frequency drive on it, so the efficiency curve is between 20 and 100% of the load, almost flat. We have the 4-cylinder. This can make, depending on the temperature lift, up to 2 megawatt. If we install several of them, we can reach 5, 6, 7 megawatt. If it's more than, let's say, 6, 7, 8 megawatt, we would use the V16. The V16 is basically the same like the V4, but has 4 times the cylinders. And with the V16, we reach a theoretical volume flow of almost 6,000 cubic meter per hour, and that's by far the biggest piston-based machine on the market. If we install several of these HBL16s on a location, we can reach up to 50 megawatt. And based on our experience, a lot of food requests are in the range between 1.5 and 30 megawatt, and in a saturated steam, it's the majority of requests typically between 120 and 180 degrees. And the important thing here is to mention is that you can do a pilot, you can do a proof of concept, proof of technology with a 1 megawatt, and then later on you can scale it up to 20, 30 megawatts. So you are also flexible how you integrate the machine, because on our experience, a lot of especially food customers in their factories are historical driven, so space is always an issue. Also how to bring in new technology, and we can do it step by step. Here you can see typical processes where we are hunting for in the food industry. So all type of drying processes, evaporation, pasteurization, sterilization, you name it. So all these typical processes. Our focus market is on temperatures above 90 degrees because that's a high temperature heat pump. And between 90 and 200 degrees, that's our core market. And then I'm also very happy and proud to announce also here, we had the press release on Monday out there that we also have a strategic collaboration with Beneo. Beneo has long-term experience in developing and producing plant-based functional ingredients. This application here seems on the first look not that exciting because it's only almost 100 degrees. However, the heat source is quite low with 20 degrees, and we can do this in a one-stage configuration and still ensure more than a megawatt thermal of output. Next one. And here, as already announced last year, we are very happy that we have Südzucker as our strategic collaboration partner. Südzucker is one of the largest food-producing companies in the world. We will deliver in 2024 several machines to the sugar processes of Südzucker, and there's the application that we produce low-pressure steam for them. And last but not least, why I'm standing here actually with Christoph. I was also participating many times on the Anuga FoodTec, and based on our experience, we have the challenge that sometimes the third party is missing. So if you look on the right-hand picture, the left arrow could, for example, be Südzucker. They can do the installation, they can do the integration, everything on their own. But the majority of the customers, they can't do the integration on their own. And therefore, we work together with E.ON, and therefore I'm also very happy that we have this strategic collaboration with E.ON, so that we together approach the customers and follow up on several projects, because the customers normally want to have a turnkey solution. We are a startup which do not have the resources to do the complete optimization of the heat supply and everything. And E.ON, of course, has the capacities to do the optimization of the heat supply, to develop customized and fully integrated solutions. And we delivering more or less just the technology. I think the technology is for E.ON also very interesting because you can cover the whole range of megawatts and temperature, and you always use the same technology base. And together with E.ON, we can also do heat as a service, so that you do not own the asset in the end of the day. E.ON can operate it for you, and the integration and all the rest of the stuff can be also handled by E.ON. And therefore, that's a very fruitful cooperation, and I'm very happy about it. And that's it. Thank you for your attention, and I'm happy to answer some questions if you have.